Hello, my exceptional math students. So today we're going to go over Chapter 3, and we're actually going to do 2 lessons, but in one video. So we're going to do lesson 3-2 and 3-3 because they both deal with just one-step inequalities. You'll see that I have a little table over here and 2 examples. So why don't you go ahead and I'll step off the screen, hit pause, copy these back down, and then I'll come on back. Alright, so now that you have all this stuff copied down, again, remember the less than symbols are always pointing towards the negatives, right? It's always pointing to the smallest numbers. The greater than are always going to be pointing to big numbers, right? Always going to be pointing to large numbers. So just think of a number line. And then remember, when we're plotting these on our little number line, the equal to's, the ones with the extra line, are colored in. The regular ones are an open dot, right? So here's our first section is just going to be adding and subtracting inequalities. And it's just like adding and subtracting one-step equations. So over here, you can see I have a y minus a 2 equals, less than 11. So I just simply do the opposite. So I just do my separation. I'm going to go plus 2, plus 2. These cancel. Y is less than or equal to 13. Pretty straightforward. Let's do my graph. Here's a positive 13. Here's a negative 13. That's a less than symbol. It's a regular, so it has an open circle. And then I'm just going to make it go smaller than 13. Like 0 is smaller than 13. That's how you know. Here, over here, we have adding 7. So you do the opposite. So again, I'm going to put my little fence. My opposite, I always go to where the variable is. That doesn't change. This is who I'm going after right there. So I'm going to go minus the 7, minus the 7. These again cross out. The x falls down. And we simply get negative 2 plus a negative 7 makes a negative 9. And then again, nice easy graph. Here's a negative 9. Here's a regular 9. Now remember, this is a greater than or equal to, so I got to make a colored in dot above my answer. So my answer was negative 9. And then it says x has to be bigger. And remember, anything positive is bigger than a negative, so it's going in that direction, right? So you can tell most of the times our graphs will always match the direction of our inequality sign. Just like here. Like I said, most of the time. So on example 3, I'm going to show you something a little bit different. Right? So I'm going to step off, go ahead and hit pause, make sure you have this all copied down. Alright, so here's example 3. So I want you to take a moment as soon as I get out of the way and copy down the sentence and then copy down the problem. So I'll step off. Okay, so now that you have everything copied down for example 3, let's go over it. So here, the x, right, it's on the right-hand side. So where in example 1 and 2, the x was over here. And we like it when the x is over here. So there is going to be something that's going to change at the end with our graphing when they put the variable or the x on the right-hand side or the wrong side. All right, so again, solving it becomes simple. We go to where the variable is, so it's over here on the right. I want to get rid of the minus 3, so I'm just going to add 3. This all is the same. These cancel out, the x falls down. Drop down the inequality sign, just how it looks. And then go 9 plus 3 is 12, right? Now, here's where I want you to pay very close attention. I'm going to make the graph right next to it. So there's my graph, right? It's small. This is a less than, and it's a regular sign, so I'm going to put a circle above the 12. But I have to be careful in how I read this one. This one says 12, because the number's coming first, is smaller than the x. That's what this says. So the 12 is smaller than the x. Well, now you got to think logic. If 12 is the smallest or smaller, then x is what? Bigger. So if I was to pick a random number, I would have to make sure that it's larger or bigger than the 12. So I'd have to say like 12 is less than, I could say 15. But now look at our graph. 15 is on this side. So my arrow is going to be going in that direction. But do you see how this arrow does not match the inequality sign? In examples 1 and 2, it did. But in this one, they're actually going in opposite directions. Now here's something else that you can do about that. So first, always solve it. But you can change the perspective. I can still come down. I can put the x first, and I can put the 12. But be very careful here. The 12 is being pointed to. It has to stay being pointed to. So the inequality sign actually kind of changes. This is a greater than, and this is a less than. But again, it's point of view. If the 12 is smaller than the x, that means that the x has to be bigger. Well, this one says x is bigger than 12. Right? It's no different than if you have a younger brother or sister. I have a younger sister. So if I said my younger sister is smaller than me, right? If she's smaller or younger than me, that automatically means I'm older, right? Greater than she is. So it's about perspective. So just remember that if they put the variable on the right side, solve it, keep it there. You're allowed to change it around, but whatever direction this is pointing in, whoever it's pointing at, you have to make sure it continues to point in that direction. Okay? So I'm going to hit pause again. Make sure you have this all copied down, and we're going to go into multiplication and dividing. All right, so now we're going to go on to times and dividing inequalities. And again, it's pretty much the exact same thing as equations. It's just there's going to be one extra little step, one little thing we have to watch out for, and it's right behind me. So again, as soon as I get off the screen, hit pause, copy down that sentence, and copy down these two examples. Okay, so now that you have this copied down, so if you times or divide with a negative, and it's very careful, it's if you times or divide by the negative. You must switch the inequality sign. Now here's what I'm talking about when I say by, right? Is over here I have a 3x is greater than or equal to negative 21. So the opposite is divide by 3. Now you see how I said divide by 3. Is this negative? No. It's a positive 3. It doesn't matter that the 21 is negative. It doesn't matter if your answer is going to become negative. This stays exactly the same. But negative 21 divided by 3 is a negative 7. These cancel out and you get an x. But again, that was because we divided by a positive 3. This stayed exactly the same. And I'm not going to graph these two. Over here, now here's the difference. Look at the variable, the x term. What does it have on it? A negative number with it. So Here's the slight difference. I'm still dividing, but I'm dividing by a -3. See? +3 dividing, don't change anything. Divide with a negative number, then this is where we're going to have a slight change. The x still falls down. Now, -21 divided by -3 happens to be a +7. That doesn't matter. What matters is you divided with a negative number. You take the inequality sign and you flip it around. That's the difference on these. That's the difference of the word by. Is if you divide by a regular number, who cares that this is negative? Doesn't matter your answer is negative. That's not why we turn things around. It stays the same. It's only if the number on the bottom that you're either multiplying or dividing by is the negative, you must switch this inequality sign around. If you do not, you will automatically get it wrong. So I'm going to step off the screen again and get ready to write 2 more examples. Take this moment to, when I get off the screen, hit pause and copy these down. All right. Here's example 3. Go ahead, hit pause, copy it down. Done. Okay. Now, 2 things to notice. X is on the wrong side. We kind of went over that with the adding and subtracting, how it kind of messes up the graphing a little bit. So we have X is on the right-hand side, or it's on the wrong side, I like to say it. And it's being divided by a -5. So when I go to solve this one, I'm going to go times, but I have to times by a negative number. So I'm timesing by the -5. And because of this, because the negative is on the bottom, because I'm going to multiply by it, these cancel out, the x falls down. -5 times -2 is a +10. But again, because I'm timesing by a negative number, I have to turn this inequality sign around. But remember, if I want my graph to match this, you always do your solving first. If you don't like the x being on this side, after you solve it, then you can turn it around. You can put the x over here, you can put the 10, but again, pay attention to who's being pointed at. The x is being pointed at. So make sure it stays being pointed at. Now, real quick, gets a lot of kids confused here, is we have a less than symbol. When we divide or multiply with that negative, it switches, it becomes a greater than. And then when we switch it around again, it looks like it's the same sign. It is. It's a less than. But again, here's the difference. Up here at the top, you see where the x is? The side with the x on it has the big mouth to it. See how ours, the side that has the x on it, is being pointed to? So you still see how it is technically still flipped. So again, this side that has the x had the big mouth open to it. When we're done, the x is being pointed at. All right, so that way our graph can match our problem. So I'm just going to put the 2 practice problems up on the board, get those done. All right, so here's your 2 practice problems. Just like in the last video, make sure that you get these done on your own and call me over when you want me to check those. Let me step out of the way, copy them down. All right, and now that you have those copied down, make sure to continue to always have a math-tastic day.